All right. Good afternoon, guys. So today we are going to see dynamic routing protocols, that is RIP version 1, RIP version 2, and then EIGRP. Okay. First, we are going to learn RIP version. That is what? Routing information protocol. Routing information protocol. Okay. And then it is a multi-vendor, multi-vendor supported protocol. Okay. And it is a distance vector routing protocol. So distance vector we have already seen, right? What is distance vector? That is based on hop count. Okay. It is a distance vector routing protocol. And then, so maximum it supports 15 routers. So hop count is, so you can say metric is hop count. Metric is hop count. That is 15 routers. Maximum 15 routers. And it uses Bellman-Ford algorithm. Bellman-Ford algorithm. Okay. And we have two versions, version 1 and version 2. Okay. And it is classful by nature. It is classful by nature, and multicast address is 224.0.0.9. Okay, write down these things. I will show you what is the difference between version 1 and version 2 in RIP. Did anyone do the practicals of static routing? How many of you got output? Please enter it in chat window. Or what are the difficulties you're getting in static routing? How many of you did the practicals? Okay. Muhammad Kasim, very easy, sir. Okay. Static routing, okay. Done. Very good. Ahmad, what about others? Prasanna, Perumal, done. What about others? Sandeep, done. I mean, done as in, did you get the output? Good. Only four, I see only 4 or 5 people. Will do it on weekend. Okay, yes, did. Okay, try to do it at least by this weekend. You have at least 2 days time. So try to finish it off. Okay, good. Some people I can see they have done. Okay, Vishal done. Good. All right. So written this. Now we'll go to Cisco Packet Tracer and we'll do a small practical. If I do the practical, you will understand it more clearly. So here I have taken 4 routers. Okay. See, a dynamic routing protocol is very easy. You don't have to advertise every network. Okay. So here I will take 10.1.1 sorry, 10.1.12.0. Here I will take 11.1.23.0. Here I will take 12.1.34.0. Okay. And then these are the networks I'm going to advertise on the routers. And I'm going to take the um, loopbacks for each and every router. So here I will take 1.1.1.1. Here I will take 2.2.2.2, 3.3.3.3, and here it is 4.4.4.4. Okay. Like this, I will take the loopbacks. So first I'll go and configure on router 1. Go to CLI, configure terminal, host name, R1, interface gig 0/0, IP address is 10.1.12.1. Everything is 255.0, no shutdown. Okay. Interface loopback 1, I'll add IP address 1.1.1.1, 255.255.255.0, and done. Okay. Now let's go to router 2. Enable configure terminal, hostname R, whatever. Enable configure terminal hostname R2, interface gig 0/0, IP address 10.1.12.2, 255.255.255.0. Oh shit. Interface gig 0/1. IP address 11.1.23.2. Correct? Yes. No shutdown. Interface loopback 1. IP address is 2.2.2.2. And then now try to ping the nearby interface, that is do ping 10.1.12.1. Okay, it is pinging. Both the interfaces are up. Fine. Now go to router 3. Enable configure terminal. Hostname R3. Interface gig 0/0. Gig 0/0. Yes. IP address is 11.1.23.3. 255.255.255.0. Wait, what happened? No, 0. No shit. Interface gig 0/1. IP address 12.1.34.3. Correct? Yes. Dot 0. No shut. Okay. Interface loopback 1. IP address 3.3.3.3. Okay. Now go to router 4. Now try to ping the router 2 first. Check the connectivity with the directly connected interface. I'll ping 11.1.23.2. Okay. So ping is working. Now we'll go to R4. Hostname R4. Interface gig 0/0. IP address 12.
1.1.34.4.
But here configured 11, correct? I've configured 11.1 dot. Correct? See, I've configured, I think, wrong. No, 12 only. Okay. I'll change it to
12.
12 only. Yes. Sorry. Now go to this router. 12.1.34.4. No shutdown. Interface loopback 1. IP address is 4.4.4.4, 255.255.255.0. Okay. Now ping the directly connected interface, that is 34.3. It is pinging. So now directly connected interface is there, but we can't ping the other networks which are not directly connected. Okay. First go to this RIP version. See, RIP version full form is Routing Information Protocol, and we have two versions. Okay. RIP version 1 and RIP version 2. So version 1 is classful, uses broadcast, and version 2 is classless and it uses multicast. That means what? This multicast address 224.0.0.9, and it uses Ballman-Ford algorithm. So maximum hop count is 15. So up to 15 routers you can ping. If it's more than 15 hop count, you can't use the routing information protocol. Then you have to go with either EIGRP or OSPF or static or default routing. Okay. And then here AD value of RIP is 120. That this already I've given, correct? AD value table. So here you have RIP timers. Hello. So every 30 seconds, they will be keep on exchanging the hello packets. Okay. And then you have invalid time, that is 30 to 180 seconds. That means if you don't get
Sir, what is hello packet?
in hello packet, they're going to exchange the information. See what I'll do. First, I'll do the practical, then you will understand. So what is the practical for this RIP version is? So in your static routing, what we are doing? See, we are not going to advertise this 10.1.12.0 and 1.1.1.0. These two networks are directly connected, locally connected. So other than this 11, 12, 2, 3, 4, 5 networks I'm going to advertise on router 1, correct? So likewise in router 2, this 10, 11 and 2 is directly connected. So I will connect 1, 3, 4 and also 12 network. This is how you are doing static routing. But in your dynamic routing, whatever the route networks which are directly connected, I'm going to advertise only those. See, for example, I'm saying router RIP. Okay. And then I'm giving network 10.1.12.0. Okay. And then I'm saying network 1.1.1.0. Only two networks I'm going to advertise. So only the directly connected. So in router 2, I will say router RIP network. What are the networks? 10.1.12.12.0. Correct. And then you have network 2.2.2.0. And then you have network 11.1.23.0. So these three networks are directly connected. Correct. I've given that. Now come to router 3. Router RIP network. What are the networks? 11 dot, yes, 11.1 dot 11.1 dot 23.0, network 12.1.34.0, and then you have network 3.3.3.0. So three networks you're going to configure here. Here, yeah, done. Now go to R4. Only the directly connected. Router RIP network 12.1.34.0. Then you have network 4.4.4.0. Done. I've only advertised the directly connected networks, not the other networks. Now try to ping from R1 to R4. I'll say ping 4.4.4.4. See, I'm able to ping completely. Now I'll ping 12.1.34.4. See, I'll be able to ping. So here it is very easy. So dynamically they are going to share the routing table. So the router 1 will share the 10 and 1 network to router 2. Sorry, router 3, because he doesn't have this router 10 information or 1 information. Likewise, this router 2, whatever information he has, he will share it with router 1, router 3 and router 4. And router 4, whatever information he has, he will share it to router 1, router 2 and also router 3. So how they are sharing this information? Through this multicast. Okay, through this multicast address, they will share all the information. So in the hello packets, what they will share means they will share the routing table, and also they will say, okay, I am connected in router RIP. He will say, I am also connected in router RIP. So they will share the hello packets. Okay, through which address? 224.0.0.9. That address, they will share the hello packets. Inside the hello packets, they will share all the routing information. Okay,
Sir,
so
sir,
that is the
sir,
use of hello packets. Who asked me this question?
sir. Dinesh, sir.
Dinesh. Is it
One
clear?
more. I have one more question, sir. I have.
Yes, please.
Suppose router one is send hello packet to router two.
Okay.
Then same hello packet is router two send to the router three or a different hello packet.
No, every 30 seconds they will keep on sending the information. This R1 will send the hello packets to R2, R3 and also R4. Okay. Again after 30 seconds, again R1 will keep on sending it. So they will keep the membership alive every 30 seconds. So they will keep on
Okay, sir.
sending
Okay.
it. That's how they know, okay, this router is alive. So that I will share the information. Okay, and R2, he will share the hello packets with R1, R3, and R4. Okay, so then you have, this is your first timer is 30 seconds. Here you see, first 30 seconds, they will share the uh, hello packets. In this hello packets, they are going to share the entire routing table. The routing table he will share with R1, I mean R1 routing table he will share with R2, R3 and also R4. Okay, so this is hello timer. What is invalid timers? So here, how long a route remains valid without receiving an update? So if I'm not receiving any hello packets for 30 seconds, okay, so that timer is 180 seconds. For till 180 seconds, it will be in invalid mode. That means if a router doesn't receive an update about the route, then that router will stay invalid for 180 seconds. Okay, and after that, you have hold on timer. What is this hold on timer? So it will not add any routes excess. That means prevents router from accepting another route after this invalid mode. It will be in hold on. It will not add any other routes. Okay. And then after 240 seconds, the neighbor will be shut down. Okay. It will become invalid and the route will marked as invalid. That means there will be no more route. That means it will remove the route from table. That is your flush mode. Okay, so first we have hello packets.
That,
Hello packets mode is they're going to share the routing table. Invalid mode means if they did not receive any updates, he will stay invalid for 180 seconds. And again, hold on. Here, no updates will be happening. And then in flush mode, it will be death. That means route will be removed. Yeah, tell me what question you have.
sir, in that diagram,
Uh-huh.
Cisco packet trace.
Yeah, this keep alive message packets. Yes, they are keep alive message packets. Or you can say hello packets. Yeah, tell
Hello,
me,
sir.
Davidas.
Yes, in that diagram, I have one doubt.
In the diagram?
Here, for this R1, we are not configuring route to that the other routes, no, 11.1.23.0
Correct.
or 2.2.2.2.
Yes.
Like earlier, we used to do like that near connected routes IP address also.
See, in this router, whatever it is directly connected, I'm going to advertise only those networks. So how he will know? Through the hello packet, he will share the information through the multicast address 0.9.
Okay, R2 will send to R1. Then only.
Yes, R1 will send to R2 and also R1 will send to R3, R1 will send to R4 also because they are all connected in one multicast group that is what? 224.0.0.9. So every four routers are connected with this address. So they will keep exchanging to each and every one. So R3 will send it to R4, R2
Okay.
and also R1. Likewise.
So we need to configure route for only the
Correct.
connected interface
Yes. Yes. Only the
and
connected. Yes.
loop back also.
Yes. Only the directly connected within the network. But we have one problem in version 1. What is the problem mean? See, here I'll say show IP route. Okay. Before that, I will do one thing. I'm going to add a network in R4, say. I will add one more loopback. Interface loopback 2, I will add. IP address 2.2. Initially, I have added 4.4.4.4, right? So now I will add 4.5.5.5. This is a different network, correct? This is a different network. That means 4.5.5 will never change. Only the fifth will change. So from 0 to 255. 0 is network ID, 255 is your broadcast ID. So 5 is a valid IP. Correct? So I will add one more, that is 4.5.5.5. So two networks I've added in my R4. So did I do routing for this 4.5.5.5? No, right? I did not give any routing. I just added the IP. Now go to this R1 and say ping 4.4.4.4. This will ping because we have given the routing. 4.5.5, it will ping or not? Did I give any routing? I did not give any routing.
No.
No,
Right?
sir.
No, I did not give routing. So it should not ping. But when I give enter, it will ping. Why it is pinging? Because one reason. What is that reason? Because that is classful in nature. RIP version 1 is classful in nature. That's why even though I don't give the routing for 4.5.5.5, it is going to take it as 4.4.0.0.0. See here, I will say to show IP router. Okay, here R means what? RIP. Okay, here you can see 120 means what? AD value. 3 means hop count. Okay, so here you can see I've given what did I give? 1.1.1.0 I've given, but it has taken it as 1.0.0.0 classful. Here I've given 10.1.11.0, but it has taken it as 10.0.0.0. So here also you can see this 4, right? It has taken at 4.0.0.0. So that's why you're able to ping directly. Okay, that's why you're able to ping directly. Now come to R2 and check the routing table. Do show IP router. See, 1.0.0 is there, 3.0.0.0 is there, 4.0.0.0 is there. So this is the reason it is classful in nature. Even though if you don't give routing, still you will be able to ping the network without the routing. This is the disadvantage we have in RIP version 1. Okay. Now I will give you the command. You can just write it down. Very simple command. Just router RIP network. Any doubt on this? If you have any doubt, use the chat window or you can even ask, up to you. How I will check the routing table? Show IP router. Write it down this. We gave 255, 255, 255. That means it should be, then how it, that's what I'm saying. That is class full in nature. So what is the range of class A? From 1 to 128, correct? In that 127 is used for 1 to 126. So 1 means what? It is in the class A range. That's why it is taking as 8. That means class full in nature. Understood? Ahmed? Yes, good. Write it down. Okay. Now we have seen RIP version 1. Now we'll see RIP version 2. Okay. So I will remove the commands here. How I will remove? No router RIP. Okay. I think no, I don't have to give this one. No, just no router RIP. Given every router. No router RIP. One I've given. 3 I will say. No router RIP. No router RIP. Okay. So I've removed everything. Now I will try to ping this 4.4.4. It will not ping. Ping 4.4.4.4. Is it pinging? No, because I've removed the I have removed the routing. Correct? So it will not ping. So now I'm going to configure the RIP version 2. How I'm going to configure? simple commands. I will say router rip, enter. And then you say version 2. Okay. And then you say no auto summary. Okay. And then you advertise the networks 10.1.12.0 network 1.1.1.0. Correct. Here I will say router rip version 2, no auto summary. Network I will say 10.1.12.0 network 11.1.23.0. Then you have network 2.2.2.0. Okay. Likewise, go to router 3, router rip version 2, no auto summary, network 11.1.23.0, network 12.1.34.0, network 3.3.3.0. Come to R4, router rip version 2, and then say no auto summary. See, what is this no auto summary command means? Take it as classless. Don't take it as classful. That is the reason I'm giving no auto summary. Okay. And then I'm saying network 12.1.34.0. Then I have network 4.4.4.0. Okay. I've advertised everything. Now I will try to think from R1 to R4. I will say ping 4.4.4.0. It is pinging. Now I will ping 12.1.34.4. It is pinging. Correct. So did I give routing for this 4.5.5.5? No, I just said 4.4.4.0. I did not advertise this 4.5.5.0. Correct. Now I'll try to ping it. See here what the difference is. Will it ping or not? Tell online guys.
No, sir.
It will not ping, but it will ping. It will ping because classless in the sense only advantage we have is when you go to the routing table, show IP route. Here you can see each and individual network they have configured. That is 3.3.3.0 you can see. 4.4.4.0 you can see. 4.5.5.0 you can see. But the problem is you will not be able to ping it. That is summarization will be taken as classless only. Only the advantage we have is in the router. That is in the routing table, you will be able to see the exact networks you have seen. See 3.3.3.0. But initially how it was taking? It was taking as 3.0.0.0. Correct. This is how it is taking. You can't see the actual network what you are given. Either it is 3.1.1.0, 3.2.2.0, 3.3.3.0, 3.4.4.0. No, you can't see that because it is taking it as class full. That means 3.0.0.0 it is taking. But actual thing is 3.3.3.0. So this advantage you have in your RIP version 2. Okay. What actual network you have advertised in the router that you can see in your version 2. But still you will be able to ping. See, for example, here I'm adding another IP. What I'll do, I'll add another loopback. Interface loopback 2. IP address I will add 1.1.10.10.10. Okay, I've added the thing. Did I give routing? No. But I will say do ping 1.1.1.1 that will ping. And then we have 1.10.10.10. See, still it will ping. Did I give routing? No. But still it will ping. When I say do show IP route. So here you can see 1.10.10.0. This is the advantage you have in your RIP version 2. Whereas in your RIP version 1, you can't see that. See, you just simply see 1.0.0.0. But in version 2, what are the actual networks I've advertised. 1.1.1.0 and also 1.10.10.0. Okay. This is your RIP version 1 and version 2. So that's why we don't use RIP versions nowadays. We use only EIGRP. Okay. Any doubt on this? Online guys? If you have any doubt, please ask in chat window or
So RIP version 2 is more useful than RIP version 1 now.
yes, only the network part. Okay. These are the comments for your version 2. Quickly write it down.
Sir, the only difference between these two versions that in version 1 we see everything will be considered at .0.0.0, and in version 2 we see exact IP only. That's the only difference, right, sir?
Yes, yes, correct. There are some small scale, like very startups, they are using it, but mostly they are replaced by other routing protocols because hop count is very less, only 15. So very small, like what do you say, startups, like they have basic routers, then they are doing this RIP version. Otherwise, in most scenarios, they are not using. Okay, written. Now we will see EIGRP.
Sir, I have doubt, sir.
Yeah, please.
Sir, there is a reason or not, sir, why only 15 hops are needed for RIP?
Why only?
Uh, the reason behind that only 15 hops are in one
That's
network.
how the protocol is
For
designed. That is how the protocol is designed. That you can't help it. That is inbuilt.
okay, okay,
Okay.
okay, okay.
All right. Now EIGRP will see. EIGRP. That means what? Enhanced interior gateway routing protocol. Okay. So here we have protocol number, that is 88, and then we have AS number. Your EIGRP works on AS number. What is AS number? Autonomous system number. What is the range? 12655535. Okay. And then multicast address. is 224.0.0.10. Okay. And then it uses dual algorithm. Okay. And after that, you can write it down. Your EIGRP is a Cisco proprietary, but it is partially open standard. As in, so there are many key technologies in your EIGRP. Only basic level of configurations you can be able to perform it in different vendor routers like HP, Nexus, Juniper. So they'll be able to configure EIGRP, what only basic level what configurations. Not the every key technologies of EIGRP is not possible. So that's why we say it as Cisco proprietary, but it is partially open standard. Okay, and then here we have metric, EIGRP metric, EIGRP metric. That is K values we see. It is K1, that is bandwidth. Okay, then you have K2, that is your load. K3, that is delay. K4, that is reliability. And then you have K5, that is MTU, maximum transmission unit. Maximum transmission unit. Okay. And here, time intervals. These K values you will learn in CCNP. Okay. Here you are not going to learn the K values. Simply write it down like this. If they ask in interview, what is the metric of EIGRP? You just say K values, that is K1, K2, K3, K4, and K5. So K1 is bandwidth, load, delay, reliability, and MT. Okay. What are these things in detail you will learn in your CCNP. Okay. We can change the metric values. Okay. All right. After that, write it down time interval. So in time interval, hello seconds is very fast here. That is only 5 seconds. Every 5 seconds, they keep on sending the messages. Okay. And then hold on interval. Hold on interval will be 15 seconds. Written? Okay. Write it down. All right. Now we'll see the practicals of EIGRP, and still there are multiple things that we will discuss. So first what I'll do, I'll remove this. No, router RIP version 2. Okay. No, router RIP version 2. No, router RIP version 2. And I will remove on router 4 also. Okay, I've removed. Now I will try to ping. Do ping 4.4.4.4. I'll not be able to ping. Okay. Now I'm going to give the EIGRP comments. Okay. See, your EIGRP is also classless by nature. You can add it here. Add one more point. It is classless by nature. Okay. Now I'll go to R1 and I'm going to configure the EIGRP. So I will say router EIGRP and give question mark. You can see the autonomous system number 12655535. I'll simply say 100. Router EIGRP 100, and then I'm saying no auto summary. Okay, that means I'm making it as classless. Now I'm saying network. What is the network? 10.1.12.0. Okay. After this, one more thing you are going to add, give question mark. Here you say EIGRP wildcard bits. Wildcard bits means exact opposite of your subnet mask. Okay. Write down one thing for, first of all, wildcard bits. I will write it down here. Wildcard mask or bit, anything is fine. So it is 100% opposite of the subnet mask which informs the router the number of octet is relevant and number of octet to ignore. Okay. Or you can say which bits should the router ignore in simple. Okay. So for example, if subnet mask is like this, 255.255.255.0, then wildcard mask 0.0.0.255. Okay. It is just exactly the opposite. For example, if we are having copy, if we are having 255.255.240, okay, then my wildcard mask will be what? Oh, not this one. Wait. 50. Okay, so 255, we are going to minus this. How much is it? 50, 55, so 15. So it is just exact opposite. Whatever the bits are on, you turn it off. Whatever the bits are remaining is off, that is your exact wildcard bits. So wildcard bits, we are going to give it in the uh, router. Write it down quickly. I will just do the practicals. All right. Written guys, now come to R1. So what is the subnet mask? 255.255.255.0. So here I'm going to advertise it as 0.0.0.0.255. Enter. Okay. And then we have network 1.1.1.0. Correct? 0.0.0.255. Done. Now go to R2. Router EIGRP 100. So every router should be on the same AS number. Otherwise it will not work. No auto summary. So network 10.1.12.0, 0.0.0.255. See, EIGRP neighborship has formed as soon as I given this command. So between R1 and R2, neighborship has formed. So another thing, network we have 11.1.23.0, 0.0.0.255. And then we have loopback 2.2.2.0, 255. Done. Come to R3. Router RIP, sorry, no router RIP, router EIGRP. Router EIGRP 100, no auto summary. Network we have 11.1.23.0, correct? Neighborship has formed. And then we have 12.1.34.0. And then we have loopback, that is 3.3.3.0. Done. Now go to R4. Router EIGRP 100, no auto summary, network 12.1.34.0, 34.0, 0.0.0.255. Give the wildcard bit also. Network 4.4.4.0, 0.0.0.255. Done. Now I've advertised all the networks. I did not advertise this 4.5.5, correct? Now I'll try to ping. Ping, I will say 4.4.4.4. See, it is pinging. Now I'll ping the 1.34.4. Ping. See, it is pinging. Now I will ping 4.5.5.5. Did I give routing for this? No. Will it ping? It will not ping in your EIGRP. Why it is not pinging? Because I've given this wildcard bits. So what is this wildcard bits? It will exactly say take only this network, not any other network. So this is your EIGRP exactly classless. Okay, so EIGRP acts like a classless. Because of this command, it will take only that network. Now it is not pinging 4.5.0. Now I'll give 4.5.5.0. 4.5.5.0. Now I have given the command. Now go and ping. It will ping. See, now it is pinging. I will add one more network in this router. I'll say interface loopback 3. I'll say IP address 2.3.3.3.0. Now I added another loopback in here, R2, correct? That is 2.3.3.3, which is a different network, correct? Will it ping from R2? No. Why? Because no routing is there. 2.3.3.3. It will not ping. So what you're going to say? Router EIGRP 100, and I'll say network 2.3.3.0, 0.0.0.255. Correct. Now try to go and ping. It will ping. So this is the advantage we have in your EIGRP. Okay. Even if you, I mean, it will not take it as classful, it will completely take it as classless, and only that network we will be able to see. See here, I will say, show this routing table. So here you have 1.1.1.0, 2.2.2.0, 2.2.3.0. So here you have D. D means what? EIGRP. Okay, that is EIGRP. See, before this, we had this IGRP. We had IGRP, but we are not using it. That again, IGRP is your distance vector protocol. In same like your RIP version, but instead of 15 routers, you can route up to 100 routers. That is IGRP. Interior Gateway Routing Protocol. We are not using that. We are using only EIGRP. Okay, this is how you check the EIGRP table. Any doubt on your practicals, guys? Online, guys? Feel free to ask.
No,
No, sir.
Everything is clear?
Clear.
Clear. Very good. Still, sir, some of theory is there for your
So,
EIGRP.
yes, I have one doubt.
Yes.
That no 100.
Yes.
Can we select any number for that,
Yes.
or is there
Any
some
range between 1 to
but
65535. Yeah, that's fine. It will work.
any
But
number?
every router should be on the same. That means all these
Oh,
routers should be on either 100, 200, 101, 102. That is between the range from 1 to 65535. It should all be on the same autonomous number. Then it will work. Otherwise, it will not work.
if we selected 10 means, so all the rows should be 10. Right.
Yes, correct. Yes. See,
Okay.
if it's 20, it will still work, but that you will learn in your CCNP, not in your CCNA level. See, today's class itself is not in your CCNA syllabus. I am taking extra class
Oh,
so that that will make you understand while you go to CCNP. Okay. So as of now, just understand this much only. That is enough. Any other doubt other than Devidas? Online guys, please respond. What is the use of AS number? AS number means what? Within the same building, like this.
same organization.
Hmm. So if I am having a Bangalore branch, inside this Bangalore branch, there are multiple routers. Sorry. There are multiple routers. But 1, 2, 3, 4, 5, 6, 7, 8. Okay. So all these routers will use same AS number. They will use same AS number. Okay. If it's a different AS number, then that is called your EGP. You remember I've said in this PPT itself. Where is it? So EIGRP means what? Interior Gateway Protocol, and this is a Exterior Gateway Protocol. Correct? You remember this? So this means what? Everything should be in same AS number, otherwise it will not work. If it's a different AS number, then you need BGP. Understood? Who is that Lenovo? Ronald, okay. So AS means it is autonomous number. We are configuring all the routers under one autonomous number so that they will communicate between that individual organization only. Okay. Is it clear, Ronald? Yes, okay. Some mic issues, so unable to talk. Yeah, that's fine. See, if you are having 100 routers, so 50 routers, I will say EIGRP 100. Other 50 routers, I will say EIGRP 200. So the routers which are in 100, they will share information within 100 only. The routers which are in 200, they will share information within 200 only. Okay. So for that purpose, we are we are to make it more. Can we have difference between AS number for different network or path? So that those things you will learn in your CCNP. Okay, different AS number is all completely CCNP. Even whatever today I'm teaching is also CCNP only. Okay, I don't want to go in detail. All right, now come to this PPT. So here you can see EIGRP means Enhanced Interior Gateway Routing Protocol, and then link state. And can we have multiple AS in the same location? Yes, you can have multiple AS. You can have, but that they will do redistribution, and then exterior gateway routing protocol will come, and then we will be doing the routing. Okay, same location you can have, and it is a okay. All right, EIGRP is a link state plus distance vector protocol, that is hybrid. Okay, and it works on protocol number 88. AD value is 94 internal and 174 external. And then you have K1, K2, K3, K4, and K5. This is your metric values, multicast address. EIGRP timer, you have 5 and 15 seconds. For every 5 seconds, they will keep on updating the routing table. Okay, if 15 seconds there is no update, then it will remove the routing table. Okay, so EIGRP has 5 packets. Now I'm going to explain you this 5 packets. Okay, what are these 5 packets? Hello. So first of all, what is hello packet? It is used to acknowledge the receipt of EIGRP packet. Used to acknowledge the receipt of packets. Sorry, this is acknowledgement packet. This is acknowledgement packet used to acknowledge the receipt of EIGRP packets. First we have hello. What is hello? Used to discover the EIGRP neighbors. That is your hello and acknowledgement packet. What is update packet? It conveys routing information to other routers, other destinations. And then you have query packet. Used to get specific info, as in if a route goes down, if when a route goes down, backup path is there, backup route is known. In this scenario, we are using query packet. And then we have a reply packet. It is used to respond to the query. So hello packet is used to discover EIGRP. Acknowledgement is used to acknowledge the EIGRP packets. Updates means if any new routing is new network is come I've added in the router, then through update packet they will send the information. Query means if there is no extra path and the route is not there, then they use the query packet. And reply packet is used to respond to the query. Okay, so these are the 5 packets they use in your EIGRP. Write down these informations.
Sir, in query packet, what is written after no? I am not able to see that.
In query packet, what?
Query packet, what is written after no?
No backup route. No backup route is known. When a route goes down, route goes down and no backup path is known. Now you're able to see?
Yes, sir.
Okay, write it down, write it down. How can routes go down? Any other ways it can go down, either device down or misconfiguration. Might be that if the device goes down, then entire route will go down. Okay. So if there's a mismatch configuration, like you said, or for example, the hello packets have not been received by the neighbor router. Okay. Those kind of scenarios. All right. Everyone written?
Yes, sir.
All right. Okay. Next we have, see, in RIP version we have only one table, but in EIGRP tables, we have 3 tables. One is neighbor table. What you will have in the neighbor table, it contains the EIGRP neighbor address and interface through which they are reached, through which they can be reached. See here. Okay, first I'll give the write down these things. First one is neighbor table, other one is topology table. Contains all destination advertised. It contains EIGRP routes. Write down these things. I will show you in practical. If you're written, just tell me in the chat window. Okay, written. All right. So now I'll show you the EIGRP tables. Show IP EIGRP neighbors. See, I have two neighbors, correct? I'm in router 2. So what is my neighbor? One is 10.1.12.1. That neighbor you can see here, correct? And it is connected via which interface? Gig 0/0. And you have other neighbor that is 11.1.23.3, this interface, and it is connected via gig 0/1. Okay. So this is your EIGRP neighbor table. And you can see AS number is 100. Now I'll show you show IP EIGRP topology. See, entire table you can see whatever the networks are there. So one network, 2, 3, 2.3.3.0, 3, 4. So complete topology you will be able to see. See, correct? This is your topology table. And what is this? Routing table of EIGRP. Show IP route EIGRP. See, if I give this command, I will be seeing only EIGRP routes. If I say show IP route, complete all the local devices also will be there. See, this big is there. If you want only EIGRP table, show IP route EIGRP. Okay, and you will see only the EIGRP routes. I will give the command here itself. You can write it down. Show IP EIGRP neighbors. Here, show IP EIGRP topology. And here it is, show IP route EIGRP. These are the comments. Write it down. Okay, written guys. So this is your EIGRP. So today we have seen RIP version 1, RIP version 2 and also EIGRP. In RIP version 1, what we have seen, it is class full by nature. Even though if I add a network, it is going to take it as class full. What is version 2? It is classless, but if I add another network, it will ping. But in routing table, you can see that exact network what you have advertised. In EIGRP, only that particular network is going to be get pinged because we are using the wildcard mask. So the wildcard mask will say which bits are to ignore. Okay, so that is the use of wildcard bits. So in EIGRP, it is going to be totally different. That means multiple things you will learn in your CCNP level. Okay, here only basic I have shown you. So in CCNP, I will show you there are multiple concepts in your key technologies in your EIGRP. Okay, that we will see in your NP. Any doubt on today's class? Online guys? Any doubt on today's class? Okay. So only today's class will be online. From Monday, I'll be coming to class. Okay. So I'll wind up here today. Only 3 topics. OSPF is a concept that I will take it on Monday. So Monday, both offline and online is there. So come to class. Okay. Both online and offline is there. All right. Any doubt other than this? No. All right, guys. Thank you. I will see you on Monday.